This is question 6B from the 2010 paper, and it's part 2. In another safety advertisement, a car is shown going into a skid. We're told that if the driver had started the skid while doing 50 kilometers per hour, he would have stopped at point A. So let's just start diagramming this out. So we've got the car coming along, it gets into a skid from this point, so skid start, and if he was doing 50 kilometers per hour, would have stopped at point A. However, he started the skid while doing 60 kilometers per hour, so it's 50, and we have to, and presumably would stop somewhere here, past the 50 point. We want to know the speed when he reached point A. Well, the best way forward for this, I think, is to consider energy, because at this point, if the person is at 50 kilometers per hour, they'll have a particular kinetic energy, and that kinetic energy will be completely converted to heat and light and everything by the time it gets to point A. That's if it's doing 50 kilometers per hour. At 60 kilometers per hour, you'll still have that same amount of energy converted at this point, point A, but the remaining energy will also be kinetic energy, and from that we can work out the speed, half mv squared, because the mass will be the same in the both, so that should cancel out. So let's just proceed and see what we come up with. First of all, we would like the kinetic energy for 50 kilometers per hour equals half mv squared, which is half times m, we'll leave m in there because we don't know what the mass is, times 50 squared, which is half m times 2,500. I'll just see if I've got a figure so I don't have to do the calculations. Well, we'll leave it at that, half m times 2,500 for 60 meters per second, 60 kilometers per hour. Remember, these are kilometers per hour, so our units for kinetic energy won't be joules, but it's for the purpose of what we're doing, it'll be fine to give us a speed in terms of kilometers per hour for our final answer. So 60 kilometers per hour, 60 times 60 is 3,600, so it'll be half m times 3,600. So the difference, because we're interested in the difference here, this is the difference in EK. That difference is going to be half m 3,600 minus half m 2,500, which will be half m 1,100, which means that this is the remaining kinetic energy, which means if we take the square root of this 1100, that should give us the velocity. So 1100 or 1100 square root is equal to about 30. What's 3 thirds 900? 40, 4 fours would be 16, so let's calculate it. Yep, 33 kilometers per hour. kph, if you like. That's how the answers do it, but kilometers per hour should be consistent with that in reality. So that's actually very fast. It's quite a speed to be still going at when you would otherwise have stopped, and that's still quite a significant chunk of kinetic energy compared to the other two when you've got it remaining there. So good road safety message.